I hope you took a few minutes to work on the problems that were posed at the end of the previous video. Let's take a look at how we can evaluate the inverse trig functions and find angle measures that equal the expression given. For sine inverse of negative square root of 2 over 2, two things come to mind. So it's the inverse sine function. So the answer, it has to be, in terms of radians, it has to be between negative pi over 2 and pi over 2. And because the ratio is negative, that means that the answer has to be down here in quadrant 4. And so thinking about what the unit circle looks like and kind of looking at the unit circle for a moment, I know that the angle, it corresponds to an angle that has a 45-degree reference angle. And so I know in degrees, the answer is going to have to be negative 45 degrees. Or in terms of radians, it would be negative pi over 4 radians. For cotangent, things are a little bit more complicated. So it's a positive cotangent ratio. I know that the answer for cotangent has to be between 0 and pi in terms of radians, between 0 and 180 degrees. And because it's a positive ratio, I know it's going to be in quadrant 1 somewhere. To think about that ratio, cotangent, it's x over y, the x coordinate over the y coordinate on the unit circle. And so what I can do is translate 1 over the square root of 3. I can translate that ratio into 1/2 over the square root of 3 over 2. And so then the coordinates that I'm looking for, they relate to a 30, 60, 90 right triangle, where the y coordinate is the square root of 3 over 2, or simply the square root of 3, and the x coordinate is 1/2, or simply 1. But if I want it to be a point on the unit circle, I have to divide both of those by 2. And that means that this angle is going to be the 60-degree angle, the larger angle, because it's opposite that larger side. And so the angle measure that I'm looking for here is 60 degrees in terms of degrees, or in terms of radians, that's the same as pi over 3. So I encourage you to think about the problems in this way, where we can use the unit circle and special right triangles to come up with answers. We can, however, also answer questions like this using a graphing calculator. And if I'd like an exact answer with a nice ratio, something that is, a nice ratio from the unit circle, setting my calculator to degree mode is going to be the way to go. So let me check the mode here. It is in degree mode. So if I want to find an inverse trig function, like inverse sine, that's the second command, the blue command on a TI-84 above the sine key. So I hit second and then sine. And so inverse sine of negative square root of 2 divided by 2, I want to get out from under the square root and then divide by 2. Since I'm in degree mode, it just gives me exactly the value that I want. It gives me exactly negative 45 degrees. Of course, I can translate that into radians and find negative pi over 4. If I started with the calculator in radian mode, it would be a little bit more complicated to get that answer because it would come out in decimal form, and right off the bat, that doesn't strike me as pi over 4, but I can check my answer, and it is negative pi divided by 4. For cotangent, we need to be a little bit cleverer about that. So for cotangent inverse, that's the same as tangent inverse of the reciprocal, right? Because the thing to keep in mind is that the ratio for an inverse function, the ratio is inside. This is the ratio. And so inverse tangent of the reciprocal ratio is going to give me the same amount. So you have to be a little bit careful, and I guess the word of caution that I'm trying to encourage here is that it's not true to say that inverse cotangent is equal to 1 over inverse tangent. Right? That is not the case. What is true is that inverse cotangent of x is equal to inverse tangent of 1 over x. And so since I can calculate inverse tangent in my calculator, if I'm interested in finding an inverse cotangent value, I can take the reciprocal of that ratio. So inverse tangent of the square root of 3 is equal to, this is pi over 3, because we're in radian mode. If I want to get to that angle measure, which is kind of a nice way to get an exact feeling for what the answer should be, I can change the mode to degree mode. And then if I find inverse tangent of square root of 3, we see that the answer should be 60 degrees. So I'd like to take a look at a couple more examples of evaluating inverse trig functions, but before we look at these answers in the video, I encourage you to pause the video and take a few minutes and either using a calculator or using a unit circle diagram, try to find the angle, both in degrees and radians, that is the value of the inverse trig function as that's shown here. So I hope you took a few minutes to find each of these inverse trig function values. Let's take a look at what the answers should be. So for the first problem we have two options. We can either think about this using a unit circle or using a graphing calculator. With the unit circle approach, what I'd want to do is think about, okay, for inverse cosine, where would that belong on the unit circle? So it's negative square root of 3 over 2. I know for cosine that I have to be either within quadrant 1 or quadrant 2. The answer is either going to be between 0 and 180 degrees or 0 and pi radians. And so for a negative cosine ratio, that's going to happen in quadrant 2. And thinking about the value that I have here, the square root of 3 over 2 as my x value, negative square root of 3, and then 2 as, so I guess I'm not really talking about a unit circle, but using 2 as the radius there. That's the reference triangle that would give me this cosine ratio. And of course that corresponds to an angle that's certainly bigger than 90 degrees. And this is going to be a 30, 60, 90 reference triangle. I know that this reference angle, it has to be the smaller one because it's opposite the shorter side of that triangle. So this has to be the 30-degree angle, which means that what's left, if I take that 30 degrees away from 180, this is a 150-degree angle. So in degrees, this is 150 degrees. And in radians, that corresponds to 5 pi over 6. We can, of course, check that with a calculator. I have inverse cosine as one of the functions on the calculator above the cosine key. And so if I hit inverse cosine and then the square root of 3 divided by 2, of course I want to make that negative, that's important. In degrees, we see that we have 150 degrees. We're in degree mode. In radians, we would get a decimal value for 5 pi over 6. For the second question here, cosecant inverse of negative 1/2. Well, before I try to work with that, let me think of this as sine inverse of, cosecant inverse of negative 2. I want to think of this as sine inverse of negative 1/2. Right. Again, this is the ratio, and so if I want to translate between inverse cosecant and inverse sine, I want to take the reciprocal of that ratio. So in a unit circle diagram, negative 1/2, it's going to be down in quadrant 4, and again we get a reference angle of 30 degrees, but this time I'm just going to take that to be negative 30 degrees. So the angle that I'm looking for is negative 30 degrees. And in radians, of course, that's negative pi over 6. Of course, just like we did with cosine, we can check our answer with the calculator. And so I'm taking sine of negative 0.5, inverse sine of negative 0.5, and we can see that the answer should be negative 30 degrees. Well, I hope you enjoyed the video. Thanks for watching.